Okay. Um, First of all, I want to say Kalamla, Yahweh, Bashmi Oshai, Bashimha, Rakak, Wadash, and double honors to the elders and apostles of Great Millstone, GMS, do rule and teach well. Today, it's not gonna be a terribly long video. I'm just gonna mention some unobvious scripture and things like that, but I don't know, I'm gonna title the video, are you sure the motb is not, the chip? Are you sure that the motb is not a chip? Because this is something that's hotly contested between different camps. Different camps say different things. I know with us, we say what it is. I don't know about Adamabot. IOIC, they say it's like a sin or something, and another group says it's a Edomite woman or something. But to really explain that, when it says what do you call it? In your head, inside the right hand or in your forehead, and you go into that word forehead, it's a metapon, it pretty much means beyond the head, so beyond your head is deeper within your head, which is your brain, and it's clearly what's going to be talked about here, the Internet of Bodies, right? So let's play this.
The brain is made of billions of neurons. Many of these are dedicated to sensory perception. But how many neurons does it take in order to create what we call a percept? We at Berkeley are bringing together engineers of physics, optics, and computer science with neuroscientists and other biologists to create for the first time the ability to measure activity in 1 million neurons at a time and to speak to those neurons, directly activating them in order to test what it means to create a perception.
To record brain activity from the live animal, we use zebrafish, transparent zebrafish, and then we create transgenic animal that have calcium sensor that could sense neuronal activity in the zebrafish. So with this scope, we could see individual area was lighting up while the fish were having seen the prey, were making the decision of whether or not to capture the prey. So in this experiment, we could see which brain area is active and where it's not active during the whole process of behavior.
In the fish, we can accomplish something that's much harder to do in the larger animals, that is see the entire brain, every neuron, and at the same time record them and manipulate them to install perception. And that will enable us eventually to develop a microscope that is this big, the size of this eraser, instead of the size of a room, basically, and to sit on the head of a human so that it replaces a missing eye or a missing limb to provide perceptual sensation of the world.
My research group is working.
All right, what do you think that is? Right? Some sort of piece of technology that goes in your brain, messes with your neurons, and are able to, in a way, like simulate, some sort of activity, to make you, feel like you're able to have sight, when in reality you don't. Right? What is that? How's that going to be done? Right? MOTB, a chip. It's very, very obvious.
Working on developing new optical imaging technologies.
Our camera technology is very simple. It consists only of a simple image sensor, and we place in front of it a piece of privacy glass like this.
When we capture images, they look all jumbled up, but using sophisticated computational algorithms, we can reconstruct 3D information.
So here's one of our first prototypes. And all we've done is taken a standard machine vision camera and removed the lens and replaced it with a piece of this privacy glass. Now on the laptop here, I'm showing you the pattern of light that hits the sensor coming from the world, and you can see that the object is completely obscured. But with knowledge of how the optical system works, we're able to undo the scrambling and reconstruct an image of the world, which you see down here. So you can see the microscope as well as Grace's face.
We place this device directly on top of a mouse's brain and reconstruct its neural activity in 3D in real time while the mouse is running around and behaving. Our goal is to look at 1 million neurons at once with single neuron resolution so that we can track their activity and try to correlate it to its behavior.
The major advance of the device we are developing is that it will achieve the ability to read and write neural activity from individual neurons. The core of this technology is an approach called digital holography, the ability to precisely shape light in 3 dimensions in the brain. We use this technology to target a very specific pattern of light into the brain to both read the activity of a group of neurons, but also to control it in real time. The goal of this project is to miniaturize such a device so that it can be implanted directly on the brain and interact in real time with the human brain. This will allow us both to answer fundamental questions in neuroscience, but also to attempt to treat a wide array of neurological diseases.
Yep. And this was back in 2015, right? See, 1 million neuron cortical modem, brain-computer interface, which is saying that they want to use it, for treating illnesses and things like that. But in reality, they're going to use it to control people, because they already started talking about that already, simulating, perceptions almost, being able to read your mind. That's what biometrics is, being able to monitor someone's biological information, like outside of them, biohacking and all that. That's what all this stuff is. Remember who's sponsoring this? DARPA, right? It was Department of Advanced Research Project or something like that. But it's all military. That's military R&D, essentially. So nothing good here. And this, as I said before, this is all the way back in 2015. They've already been talking about this. So makes it very painfully obvious what all this stuff is, what it ties into. And BlackRock, they've already done experiments and stuff like that recently, which is like what, 7-8 years later, so you do the math, you see they already had this kind of tech and they're already thinking about this stuff, 7, 8 years ago, right? When they start doing things like that, this is really something that's been thought about for decades. It's always been out there. These things don't just pop up out of nowhere. It's always planned. So yeah, that's what's going on here. We could play a little bit of the rest.
The brain-machine interface, or BMI, is an ideal platform to demonstrate the impressive capabilities of this optical imaging technology.
As you explore your environment, your perception of objects that you experience are generated by specific action potentials that occur in specific sets of neurons in your brain. What we're doing here is trying to develop a new technology that will allow us to use light to directly control the sequence of action potentials that occurs in space and time in the brain of an awake behaving mouse that's exploring its environment. Using this approach, we're hoping to be able to parse the neural code and directly generate novel perceptions in this mouse in order to understand how the neural code generates your representation of your world.
While the data are being collected, we need to process it in real time.
Right, and what do you think they're practicing for? They're practicing for you people, man. As soon as they get, well, who knows if they already have that ability, but by the time they have the motb out there, they're going to be able to make you see shit and hear shit and just be able to fuck with people, man. Make people go crazy and shit, This is all stuff that they're practicing, man. They've already practiced this stuff since 2015. All right, so all the info, all the tech, it's already there, man.
Real time, frame by frame. So the data comes in, we extract the neurons, and we extract the neural responses. We then use these data to fit an encoding model that describes how the neuron responds to different features of the stimulus. Once we have that encoding model, we can use it to decode brain activity and determine how the brain would respond to new images that the animal never saw. And we can inject those responses into the brain in order to elicit an illusory percept in the animal.
In a scientific career, it's rare that you hit something that brings you so close to the cusp of discovery. A device that can read activity in 1 million neurons and speak to those neurons and control them is one that can break open the basis of perception and memory.
But what about what happens at the synaptic connections between neurons? And that goes wrong in diseases like Alzheimer's and Parkinson's disease. The window to the brain that we have will enable us there too to make manipulations, and ones that potentially could be therapeutic in a way that could never be achieved before.
Okay, so pretty obvious what all this stuff is. And yes, it will, be your undoing if you do take this stuff. So yeah, that's pretty much it. As I said before, DARPA, right? DARPA to build an implantable brain-computer interface that one day may be used to restore sensory inputs to those who have lost them. Yep. So pretty clear what this is. What's going on here. Yeah, it's a show.